Hello there. Thank you very much for tuning in to watch this video. Today I want to talk about formation of ions, valences, and the chemical formula. What we can call the ion is a charged particle of an atom or a group of chemically combined atoms. You could call them radicals by gaining or losing electrons. If you look at an example of sodium, when it loses an electron, it becomes a positive charged ion. In case of chlorine, if it gains an electron, it becomes a negatively charged ion. So that's why we are defining the ion like that. The positively charged ions are called cations. They are formed when atoms lose electrons to acquire a stable electronic configuration, that of a noble gas. The negatively charged ions are called anions. And we have said already that those ones are got by gaining electrons to become negatively charged. So that's how we can differentiate between cations and anions. Formation of cations. These are mainly formed by metals. Metals are in group 1, group 2, and group 3. So these atoms with fewer electrons will easily lose electrons since they require a smaller energy compared to those that have more electrons, the outermost shell. Example, we see sodium ion will just be formed by losing one electron. Remember, sodium had a configuration of 281, but it becomes 28. The structural representation of this, you can see there is only one electron in the last shell of sodium, and when it loses that electron, it becomes 28. And that is, you put a curly bracket and put a positive charge outside the bracket. So that's how we can form the sodium ion. You could also represent the structure in another way, as you see in the diagram. The outermost electron is lost, and then you get the sodium ion, which is positively charged. The sodium atom is neutral, so it has a zero charge because the electrons are balanced up, protons balancing up with electrons. But when it loses electrons, they don't balance up, that's why it gets that charge. If you look at also another for the formation of anions, these are negatively charged ions, as we said, and they are formed by gaining electrons so as to acquire a stable electron configuration as that of noble gas. They are formed by nanometals, i.e. group 5, group 6, and group 7. And even those that require fewer electrons will need a smaller energy to combine, like the chloride ion. The structural representation of this, you can see that is 287, that's the chlorine atom, and it will have a zero charge because the protons are really balancing with the electrons, but then it gets a negative charge when it gets an extra electron, because the balancing now will not be balancing. That is what we can say. So that's how you can form the chloride ion, by having an electron being added, as you see in the diagram. So you get the chloride ion, which is negatively charged. So that structure shows this very well. And still you can put a curly bracket and you put a negative charge outside the bracket. So that is how we can show that, and it gets a stable electron configuration of that of argon, which is an inert gas or a noble gas. So that diagram illustrates what we are talking about here. Sorry for that blackout, but I was trying to show you more of that. We can just continue with our representation. So we have a small quiz here. Illustrate with diagrams the formation of aluminium 3 ion, magnesium 2 ion, and the oxide ion. So you can try those ones by pausing the video and try to see if you can really get those answers. So let us try more illustrations to show more of this work after this. A valency is the combining power of an element or a radical, or you can say the number of electrons lost or gained by an element or radical in order to attain a stable electronic structure or configuration. So the radicals, we can remind ourselves, these are a group of atoms that exist in several compounds but do not exist on their own, or does not exist on its own. Like, you can talk about a carbonate, that's CO3, chlorate, ClO3, ammonium, you can have all that. We can have example of elements and their valences. As we saw in the periodic table, you have hydrogen, helium. The way you look at them in the periodic table, that the atomic number, then electron configuration, the number of electrons in the last shell will help you to tell the valency. If it's group 1, the valency will be 1. Group 2, the valency will be 2. Group 3, the valency will be 3. Like that, like that. So that can help us to get the valences of the elements in the periodic table. Then the radicals, as we said, a group of atoms which are chemically combined, or which exist on their own, but do not several compounds do not exist on their own. We can have some of the examples. Ammonium has a valence of 1, carbonate, a valence of 2, hydroxide, a valence of 1, like that, like that. So we can have a variety of those in our table here, because we shall use them in the various calculations that you're going to do. A chemical formula is a representation showing the proportion of elements present in a chemical compound using symbols. It consists of symbols of the elements and a number to show the ratio in which the different atoms are present. So if you talk about H2O, it shows 2 atoms of hydrogen and 1 atom of oxygen. If you talk about carbon dioxide, 1 atom of carbon and 2 atoms of oxygen. So those illustrate that, and we can use this really tell. So important concepts about the chemical formula. The number written as a subscript after a symbol of an element indicates the number of atoms of that element chemically combined. Example, H2O. You can tell calcium carbonate, CaCO3, sulfuric acid, H2SO4. For a group of atoms or radicals, a bracket can be used to show that O bracket will have the same valency. Example, if you talk about calcium nitrate, Ca, and so on and so forth. Steps in writing a chemical formula. Identify from the name of the compound the elements and radicals present. E.g., sodium chloride, there is sodium and chloride radical. Write the symbol of the element or formula of the radical separately, beginning with the one of the metal or ammonium radical, followed by a non-metal or a radical. Like if you talk about sodium chloride, start with sodium, which is a metal, and then the chloride comes next. Then write the valences as subscripts, like that, as you have seen. Subscript 1 for sodium, subscript 1 for chloride, and then you interchange them. And then if you find that they can be written in the same ratio, you just bring them close to each other and cancel them out. If they can't be in the same ratio, you just, for example, if you talk about magnesium chloride, you put a 2 on the chloride and then 1 on the magnesium. Like, you switch them like that. It becomes MgCl2. More about the valences of the formula. If the valences are not the same and have no common factor, just interchange them. Sorry for the blackout. And then you just interchange them, and then you do as we said in magnesium chloride. If it has a radical, then you can put brackets, and then the number will be put outside the brackets to indicate its subscript for the all radical, as we saw in magnesium sulfate. Oh, you can look at this example for magnesium hydroxide. If you put a 2, you have to put OH in brackets and put a 2 outside, because the 2 is coming from the magnesium. So that illustrates it very well in this example. We can try it for more examples, as we have said. So that is why it's written in that way, or in that kind of illustration. We can try more examples here. Sorry for that small blackout, but we can try some more examples to illustrate more of these radicals and the brackets, and those that do not have common. So we have many examples we can try here, as we are going to see. We have seen that one of magnesium hydroxide. We can also try others. Calcium carbonate, copper. You can see how we are switching them. The 2 going in the hydroxide and the 1 going in the magnesium, like that. So we can try it also with other examples. For copper carbonate, we can try it with the calcium carbonate. We can try it with the calcium hydroxide, and many examples as you can see here. So we are seeing magnesium chloride. It will be like that, as we illustrated. The 2 will come on the chlorine, or on the chloride. Calcium oxide, because they are both having 2, the 2's will cancel out and remain with CaO. Copper nitrate, now they put a bracket on the nitrate because it has a valence of 1, and the 2 will come on the nitrate. Aluminium chloride, because aluminium has a valence of 3, chloride a valence of 1, becomes AlCl3. You can try more with other symbols like sodium oxide. Sodium having a valence of 1 and oxide a valence of 2. The 2 goes on the sodium and 1 on the oxide. And then you can try it on sodium sulfate. Of course, there you shall have to put 2 on the sodium, and then the sulfate does not need it has a 1. Then magnesium hydroxide, as we said, a 2 will go on the hydroxide. So you can try this small quiz and see if you can practice how to get magnesium chloride, calcium oxide, copper nitrate, aluminum chloride, and calcium carbonate. Thank you very much. Don't forget to subscribe on this channel for more videos on